All right, I think we'll start. Um, so welcome to this talk about Kubernetes security with Istio. Originally, when I started looking at Istio, we were looking at it for a client, and it looked rather interesting. It has a lot of interesting properties, and I really wanted to sort of dive into it and see what it could do. And the end result of this was this talk. So I'm Alan. I work at Blank. I normally work as a developer, but also with some security testing and all kinds of other stuff in there. Um, I build open source security tools, and I'm head of the OWASP Norway chapter as well. Before we head over to Istio, we're going to discuss a little bit about container threats. So in Kubernetes, we have this thing called pods. And a pod is basically a deployment unit. And usually it's one container. So we have a pod, the pod has one container. It can have multiple containers, but the usual is to have one container in a pod. So in this case, we have two pods. We have a pod with service A in it and a pod with service B in it, and we have multiple of each. These are usually deployed on nodes, so they might be on the same node or they might be on different nodes. In this case, I have them on different nodes. And then we have our, not friend, our enemy, the hacker that wants to hack this solution. So the hacker might try to listen in on traffic between these nodes or between these pods. The hacker might try to attack one of these pods and gain access into the pod. And if the attacker is able to do, let's say, a remote code execution attack and get access into the pod itself and breach that, the attacker now has some more options. Because maybe the attacker can now start to attack other pods that are not available from the outside. So maybe service B had an open port to the outside world, but service A didn't. But now, because the attacker has been able to compromise service B, the attacker is now able to attack service A. The attacker could also do something else, which is to try to compromise the node. So do a container escape and become either a normal user or the root user of the node itself. And this last threat is not something that Istio can help us a lot with, but some of the previous stuff is something Istio can help us with. So Istio, this is the logo of Istio. It's kind of a sailboat, and I think Istio means sail in Greek. So we have this nautical team on Kubernetes with the steering wheels and everything in it. And the idea, as you can see the tagline here, connect, secure, control, and observe services. So Istio offers more than just security, but a lot of the features that it offers can be used for security as well. So Istio recently hit the 1.0 milestone. So this was in August last year, and the current version is 1.0.5. And they're fixing small bugs. They're doing all kinds of improvements to it all the time, and it's quite an active project. It's on GitHub, and it's built on top of things that have come out of Google, and especially Lyft, which we'll get back to. But then IBM, VMware, and Cisco, and a lot of other companies are also contributing to Istio. Istio adds to Kubernetes something we call a service mesh. And it's kind of hard to explain what a service mesh is. The only sort of explanation I could find that made some kind of sense was it's the network of microservices and the interactions between them, because we're kind of adding stuff that's not there at the moment to Kubernetes to make things better. And a service mesh typically adds things like discovery, load balancing, failure recovery, metrics, and monitoring, which are all interesting properties. But they could also include other things like A/B testing and canary releases, so we can push out a new version and just direct some of the traffic to this new version. We can do rate limiting, we can do access control, and we can do end-to-end authentication. This is one of the things that Istio adds. Istio has some security goals. The first one is security by default. And this is a very, very interesting property, because what they aim to do is allow you to add a certain amount of security to the applications without changing them. So you deploy something and then you kind of wrap it you wrap Istio around it to protect it. So you can use it with any type of container. It doesn't have to be Java or Node or something specific. You don't even have to have the ability to change the code. They aim to have a defense in depth. So this is going to be add-ons to existing security things that you might have in your network or on your hosts. And they also aim to support what we call a zero trust network. So if we can't trust the network, we still want to be able to communicate between these workloads, as we call it, or the pods, in a way where we know that no one's listening in or changing the traffic. So we have our trusted services once again, service A and service B. And what would normally happen is a service or a pod would speak directly to another pod. But with Istio, we're going to do things a little bit differently. We're going to introduce proxies. So these proxies are in the same pod, so they're a new container in the same pod. And instead of speaking directly between the services, we now only speak to the pod. And then the proxy. And the proxy speaks to the proxy at the other end, and this is how we now communicate. So there's no direct communication between service A and service B. And this is how we can add things to this container without actually changing the service itself. So let's look at what's going on here. So we have what's called a sidecar container. So the proxy is a sidecar container. We also call this out-of-process architecture because we're adding new stuff without changing the existing code. We're adding a new process that handles some of the security for us. And as I said, this allows us to add a lot of things without changing the existing code. So let's say this was a database or something that we just purchased from someone and we want to deploy this on our cluster. Now we can actually add more security, more metrics, more things to it without changing that code, which we might not even have access to. It's also a way that we can do this across different types of systems. So it doesn't have to be all Java or Node.js. As I said, you can use this across different types of pods or services or containers. So what's used in Istio is something called the Envoy proxy, and this was created by Lyft, and it's written in C and C++, so it's really high performant, and it does a lot of things. It can do dynamic service discovery, it does load balancing, and you can see all the other things there. So it doesn't just do HTTP, it also does gRPC. And we can add things like circuit breakers. We can add things like stage rollouts with percentage-based traffic split. And this is kind of important because you can't normally do this in Kubernetes, but because you're limited to the amount of pods you have. But now you can set a percentage. I want only 1% of this traffic to go to the new version, and then the rest should go to the old version. So you can slowly roll out the new version. We can do things like fault injection to test the resilience of our applications. We can get richer metrics, and we can do TLS as a part of the proxy. So, but that's not all we get from Istio. We have a few more things here. We have what we call the control plane, which actually controls how these proxies work together. In there, we have something called the pilot. And the pilot is when we want to configure these proxies, we send in policies. And what the pilot will do is push those policies out to the proxies to tell them what they're going to do, what they're going to allow, etc., etc. We also have the mixer. The mixer is a thing that mainly collects information. So it collects metrics, it collects all kinds of things around what's going on, but it can also do evaluation of things. So the proxies can ask the mixer, is this thing supposed to be allowed? And then the mixer can say yes or no. And the third part here is called Citadel, and we'll talk a bit more about that one later. But it's the thing that helps us with certificates and secure communication. We have a couple of more things there. We have what we call ingress and egress. So ingress is what controls what comes into the cluster. So this is where we open up endpoints to the outside world. And we can apply these policies all the way out to in the ingress, or we can apply them on the proxies themselves. And similarly, we have an egress. And what's great about having an egress here is that in the egress, we can control where you're allowed to connect to. And we can even use this also if we have multiple clusters where we have Istio installed. We can use these certificates that we're going to set up. We can use them across the clusters. So this one controls how we speak to the outside world. We don't have to use it. We can let the pods themselves speak directly to the outside if we want to, but it can add a lot of extra security if we can control every outbound communication from any of our services. So back to this proxy. The applications that we deploy, they're supposed to be unaware of this proxies because we are supposed to be able to add this to our applications without changing them. And I was wondering about this when I first read about it, like how does it actually hijack the traffic? Because I mean, you could easily create your own proxy where you would, in your code, you would have to tell it to use the proxy. But in this case, this just happens. You just deploy it and it suddenly starts hijacking all the traffic and managing it. And I was kind of confused about this at first. How can one container in a pod hijack the traffic of the other container in the pod? That sounds like a problem security-wise. But the thing is, containers in a pod, they share a network namespace. And I'm going to show you this, what actually happens. So I have a small Kubernetes cluster running on my laptop here. And I have, as you can see all the way to the top here, I have this container called NetTools. And it has 2 containers in it. So what I'm going to do now, I'm going to go into one of these containers up here. So it's going to be NetTools 1. I'm going to go into this one. Oh, just have to remember to add. I'm going to get a shell into this container, and I'm going to do the same thing down here with the other one. So now I have a shell in 2 different containers, but they're in the same pod. So if I try to check here, is there anything listening here? There's nothing listening at all. There's no listeners at all. I'm going to set up a listener down here. So I'm going to say, okay, I want to listen in on localhost because that wouldn't be visible from the outside. And I'm going to listen at a specific port. If I now go back to the other pod and check, we can see it can see this listener because they share localhost. Localhost is the same thing for these 2 pods. What's interesting though is there's no PID here. There's no process ID. And in fact, if I try to do to list all the processes, I can't see this netcat that I'm running in the other container because they don't share the process namespace. They only share the network namespace. So they can see one of the things, but I can't see the other. They can see something is listening, but they don't know what it is. But this is also a way for 2 containers to talk to each other within the same pod. You can do this in normal Docker as well, just by first starting one container and then set the network of the second container to be the container network of the first container. So something like the line I'm showing up here. So you can do the same thing if you want to try it out. You don't have to have Kubernetes. What we're going to do when we're deploying something with Istio is we have this new tool. Normally when we're using Kubernetes, we have a kube control or a kubectl. With Istio, we get a new thing called Istio Citadel. And what this one does is we can sort of add the stuff that we want from Istio to an existing Kubernetes deployment. So we take a file that we have that describes the deployment, and we just do this kube inject thing, and it's going to add some new stuff to it. So in this case, we see that it's added a new container. We see that it's called the proxy, which you can see down here. It runs as user 1337. This number seems to be a number that they use a lot, lit. And so they're adding this new container. We can also see there's something here called control plane policy mutual TLS. So they're adding mutual TLS, etc. And you can add all kinds of stuff in here. But so it's adding this new container. It also mounts some certificates and things down here. What it also does is it uses something called an init container. So we talked about a sidecar container, but what's an init container? Well, an init container is a container that runs before the other containers. So the init container can do things to set up the pod itself for the containers that are coming after it. So one of the differences between a normal container and an init container is that an init container runs to completion and then stops. So it only runs at the beginning and then it stops while the other containers are running until you kill them. And in this case, we also see something all the way to the bottom here. We see that for this container, we have a special capability called netadmin. And now we're kind of starting to see what's going on here. So it needs the netadmin capability, and the netadmin capability allows us to redirect traffic. aha, so there's something here that's going to redirect the traffic from this service pod and into the proxy. And if we look at the repo, the GitHub repo, we find that there's something called Istio IP tables. I don't expect you to read all of this, by the way. I'm just showing you. So what it does is it redirects traffic from all the incoming traffic is redirected into a certain chain, and then it's sent to the proxy and then back and forth. And actually, a guy called Jimmy Sung has created this really useful blog post about this. Again, I'm not going to go through the diagram here, but you can see the traffic's coming in from the left. It's going into pre-routing. It's sent to Istio inbound, and then it's kind of sent to the proxy back and forth so the proxy can do its thing. And then towards the end, it's sent into the app container. And then from the app container, when it goes out, it also goes through the proxy due to this routing. And then the proxy can add all kinds of stuff to it, or do policy evaluation and things like that. And then we actually send the traffic out. So if you want to learn more about it, go read this blog post, or at least look at this diagram in more detail, because it's really useful. One of the things I was wondering about with this was how can if we redirect the traffic using IP tables, and we have an outbound connection, it's going to google.com, and then we have something that hijacks it and sends it on to another service. How can this service that gets it know where it was supposed to go? And it turns out that there's a way to get socket options in C, and I'm not a C programmer, so I didn't know this originally. But if we redirect this using IP tables, we can ask the socket, but what was your original destination? So that's the second line here, and we can do this from even from JavaScript or other languages. We just have to find the right APIs for it. But that's how it knows what was the original, the proxy knows what was the original location of this, because there's no normal proxy headers that we would have in HTTP where we're like saying, well, connect to this thing, and et cetera, et cetera. It's all on the socket level. So a side note on this net admin capability is that this is a thing that's had a lot of bugs around it and some CVEs. So it's not something you want to let your containers have while it's running. So they made a really sane choice in this architecture, that they use it only in the init container and let that set up the traffic so it goes through the proxy, and then it's dropped. So you don't have that capability in the containers anymore. That's not something you want to have. There's a really good paper from NCC group called Understanding and Hardening Linux Containers, which I highly recommend you read if you're interested in Docker and container security. Routing and policies. We can do a lot of things with Istio around routing and policies. So we can do automatic load balancing for many different types of traffic. We can do a fine-grained control, so we can do things like circuit breakers and retries. So we can say, well, if you try to connect to this thing and it's not answering, well, wait a bit and then try again. Or we can fail over to different services if one of them is failing. We can also do things like policies, and this can be interesting in terms of denial of service, for instance. If one of our services is really hammering on one of the others, it might be useful to introduce rate limits or quotas, and we can also do access control using Istio. The communication itself is set up using mutual TLS, or at least we can set it up to use mutual TLS, and we can use this as a way to get authentication and authorization. But before we go into detail on how that works, we're going to sidetrack a little bit and talk about something called SPIFFE. SPIFFE is the Secure Production Identity Framework for everyone. It's on SPIFFE.io, and it's inspired by something Google created called ALTS, Application Layer Transport Security. One of the ideas here is, when we're starting deploying containers and all kinds of application microservices, we don't really care that much about the host name anymore, because these things will move around. They won't stay at one host. They're going to move around from different nodes to all kinds of places. And so using host name as the identity of a, let's say, a certificate, that doesn't make much sense anymore. What we want to know is the workload. So we want to know, am I speaking to the right type of process. Am I speaking to the right type of microservice? I don't really care where it is, as long as it has this way of proving that it is the workload that it's supposed to be. So we have workload or service identification instead of host identification. In SPIFFE, we have a kind of URI-based scheme, which is called the SPIFFE ID. And the SPIFFE ID has an issuer as the first part, and then we have some kind of identifier on the right side. This doesn't have to be hierarchical. It can be, but it doesn't have to be. But we have the issuer of the of this ID, and then we have some kind of identifier for the service itself. To prove your SPIFFE identity, we have a SPIFFE verifiable identity document. And this contains the SPIFFE ID. It contains a public key and it contains a valid signature. So this is, of course, normally implemented as X509 certificates. And this is what Istio is using as well. Usually these things are short-lived as well. We want them to be short-lived. We want to issue new certificate often and then just remove the other ones and have them expire as fast as possible, basically. So if we're going to use SPIFFE, we can use something called Spire, the SPIFFE runtime environment. And in this case, we set up a Spire server over here. And we have a node agent that runs on a node. And the node agent, we first have to register it with the Spire server. So it sits there. And what the node agent does, it does attestation. So when we fire up some kind of a service on this node, the node agent knows something about this service. It can know what container hash it has. It can know what kind of a process it is. It can do all kinds of attestations to figure out what is this service that's now trying to be a part of this network. So the service will just simply ask the node agent, who am I? And the node agent will then go to the Spire server to get some kind of credential for this. And then from there on, the service can use this credential to speak to other services. So why am I talking about SPIFFE? Well, Istio Auth, the authorization and authentication part is, or at least the authentication part, is considered a SPIFFE implementation. The SPIFFE people are really often saying, Istio is one of the implementations of SPIFFE, while the Istio people are more in terms of, well, Istio has a SPIFFE implementation, but it also offers a lot more. What it does in this case, instead of having this Spire server that's a very different thing in these node agents, so we're using the underlying platform, which is Kubernetes, and we're using that for attestation. So that the platform itself knows which pods are running where, and we can use this to give them certificates. But so Istio Auth is more comprehensive than Spire because it doesn't just do authentication, but it also does authorization and auditing and all kinds of metrics and things like that, so we can get from Istio. And here we come back to this Istio Citadel, because this Citadel was something formerly known as Istio CA, because it's kind of a certificate authority. It creates the certificate, creates these SVID documents for us. And it actually runs as a Kubernetes pod itself. So I can show you quickly just what happens if we list out what's running in our what's going to happen when you install Istio, which is quite easy, is you're going to get a new namespace called Istio System. And within this Istio System namespace, there's going to be a set of pods running. So we can do this. We're going to see the pods that's running. So we see the Citadel as the second one up here. We see the egress and ingress gateways, and we see the pilot and some other things as well in here. So the Citadel, it runs as a Kubernetes pod. It sits in the Istio namespace, but it has some rights into all namespaces in the system. It has a CA certificate. If you don't provide one to it, it's going to create one, a self-signed one. But you can, if you have an existing PKI, you can, for instance, you can issue an intermediate CA and you can plug that in and have it use that one instead. So the Citadel has rights to all the namespaces on your cluster because it needs to be able to create secrets. So secrets is where it stores these certificates. And it needs to be able to watch these secrets to see what's happening through them. So, and it also looks for service accounts and services, which we'll get back to. So these SVID documents in Istio, they're created by this Citadel. it's per service account. So it's not really tied to the workload as such, but as long as we run each pod or not each pod, but each deployment with a unique service account, this works as intended. The default is that these certificates are valid for 1 hour. So they're really short-lived certificates. I mean, we're used to having certificates that are valid for a year or two, but now we have certificates that are valid for only 1 hour. So if someone steals one of these, it's quickly going to expire. They're also refreshed every 30 minutes, so you won't have these delays where you try to renew something and you're too late and then you're going to get an outage. So we have a 30-minute gap. These things are all configurable, so you can set them up with different time limits if you want to. So the certificate only contains the SPIFFE ID. There are no DNS names in these certificates. And this can sometimes be annoying if you're trying to do like a cluster where you have some things using Istio and some things that are not using Istio. Typically, a Java application will have problems or talking to one of the SPIFFE things because it's going to hit a certificate that doesn't have a DNS name and it's not going to be trusted by default. As mentioned, these certificates are also tied to the service account, so you can, if you want to, you can boot up multiple workloads that are very different with the same service account, and thus they will get the same certificate. An interesting thing that I noticed when I had worked on this for a while, trying to look at what it's doing, we installed it and we're using it a bit, is a bug that was introduced in 0.5.1. This is the commit that fixes the problem, but the problem in this case was that they introduced a grace period as a config setting. So you could say how long before the certificate expires are you supposed to renew it? But the problem was in this case that they were using integers, and they weren't aware that they were using integers. So in this case, we ended up with, if you set the grace period to 0.5, it would become 0. And so the certificates would not be renewed until after they had expired, which is kind of annoying. So you get like a 1 minute gap once per hour where everything would fail and like, what's going on? Why is it failing? And I was reading through the code and I actually found this thing. And then I went back and saw, well, they've actually fixed it in a newer version, and I wouldn't have had to spend all this time reading code to figure out what was going on. But the weird thing was that this was in 0.5, which at the point was supposed to be like a long-term release, at least for a while. But they fixed it in a short-term release, which was 0.6, and I tried to make them fix it back in 0.5, but they didn't want to. But this is fixed now, of course. So we're using mutual TLS between these services or these pods, and so we're creating these TLS channels. So this doesn't have to be HTTPS. I mean, it doesn't have to be HTTP. It can be any type of TCP connection. And we can enforce this on either a cluster level. So we can say that all the pods that I have in my cluster now, they are going to use mutual TLS between them. Or we can say that only the pods within this specific namespace, they are going to use mutual TLS, but the other ones I don't care about. Or you can also do it on a service level. So this is kind of the way that we set this up. We're using these rules. So in this case, we're saying TLS mode Istio mutual. And if you're going to speak to something at start.local, you have to use this. And there you can see the URI down at the bottom. On the Istio document pages, there are a lot of tasks that you can do to learn how this works, which is really useful. This is the way that you used to do authorization back in Istio 0.5. And this was kind of horrible the first time I looked at it, to be honest, because this is a blacklist approach. So we have a deny product handler denier, and we were saying like, well, this SPIFFE ID here is not allowed to talk to us. And of course, this is not the way we want to do security. We want to say who's allowed to talk to us, not who is not allowed to talk to us, because that would be really hard to get right. And luckily, they fixed this in later versions. So we now have a much wider way of doing authorization as well. So in this case, we have a couple of rules. Any services that start with tests, anyone can call them. But if there's a service called bookstore.default SVC cluster local, and you're trying to go to the reviews paths, and using get there, you can add constraints. So we can do kind of fine-grained authorization here. I'm not sure that I think this is a good idea. I would rather use like an authorization that says you're allowed to speak to this service or not, and put the actual authorization in the application itself, but it's possible at least. Here is another. Here is how we bind this. We created this service role, and then we can bind this role to a service account. So in the previous version, we had everything in one, but now in the latest version of Istio, we have two different. So we create a role, and then we bind the role to a service account. So we allow them to talk. We can also do something like this. So we have this properties request auth claims email. Okay, what's this all about? Well, actually, Istio doesn't just add service-to-service mutual TLS, but it also adds a way to do end-user validation. So this is implemented. For now, it supports JSON Web Tokens, JWTs, and we can have Istio check the signature of these tokens on their way in, instead of having to do it ourselves in the applications. And it supports Auth0, Firebase, Google Auth, but you can also do your own if you want to. And it's actually quite easy to set up. So in this case, we have a service, and what we configure it to do is we're going to say, this is where you find my my JSON web keys, on this location here. And if you ever see a token coming in with an issuer called demo, you're going to use the public keys that you find on this location to try to verify it. So I have an example of that as well. So in this case, I have a service that's deployed on my cluster, and if I try to invoke it, I get a 401 unauthorized, as you can see up here. If I look at what's actually deployed in this cluster, it's I have added a policy, and the important parts are what you see down here. This is the demo key store, and the demo issuer that's used if you do the tasks for Istio that's in the documentation. So I have to have a token, and luckily I have a token as well, so I can try to call this with the token. Should be here, and actually it's failing right now. That's fun, always fun. Probably it might be because I'm not connected to the internet and I can't download the JSON web keys, so it's gonna fail. Normally, what would happen is it would add the original, or it will forward the original token in the header to the end target service. Yeah. So the Istio authorization is coarse-grained. It's on. You can do like path-based authorization. You can do source-based authorization, but I'm not really sure that this is where I want to add those kinds of things. I've seen these things go wrong many times, so I'm not sure that that's what I want to do. And there's also some other thing that's a bit annoying at the moment, and that's Istio. It doesn't forward the SPIFFE identity to the container as such. The authorization stops in the proxy. So the application itself has no way of knowing which service was calling it. So if this was like, let's say this was a search index or something, and you wanted to have different search indexes for different microservices, there's no way for the pod itself to know which service is now calling and which data to provide. I added this as an issue in the GitHub repo, but that issue repo has now been renamed to old issues repo because they now moved all the issues to a new repo, but it didn't move mine. But then someone else actually added a new issue on the new repo, and they're now considering adding this in 1.1, so you can actually get the SPIFFE ID all the way into the application and know who the callers are. You can also use these Istio certs without the sidecar, so you don't have to use the proxy. And this can actually be a bit useful if you, let's say you at the moment you want to be able to know which certificates are coming in or which clients are calling you, but you don't want to use the proxy because you want to have the certificates all the way into your application. What you could do then is you could set up an Nginx, for instance, and you can use that to verify the certificates and then forward the identities into your applications. So because these certificates, they're just Kubernetes secrets, which also means that they're just stored as base 64 encoded stuff in the cluster. But yeah, you can use them, you can mount them into your own applications. So what I usually do is when I've done this is I mounted them as volumes into the containers, and then actually what Kubernetes will do is whenever the secret changes, it will update the volume that's mounted into the application. And this is contrary to popular belief that, like, when you start a container, if whatever changes you do to the secrets, it's not going to be reflected and you have to restart the containers, but secrets are actually updated. And I have a demo of this as well, because we can set up an application that's like kind of listening for file system events and then reloads the certificate. So in Node.js, we can simply do something like this. I've mounted the certificate under /secret, and then I can do fswatch to watch for changes. And whenever there's a change, I'm going to notify the clients. So I have this tiny little website here, which it now has a certificate that's loaded. You don't really have to read what's up there. It just says there is a certificate, and it was loaded. And I'm now going to go in and show you what we can do with this, because we now have these secrets here, and you can see the Istio secrets are called Istio dot and then the name of the service account. And the type is istio.io key insert. So within such a secret, we have the private key, we have the public key, and we have the CA chain. So we can mount these in. But what happens if we delete one of them? So now I'm going to delete the one called Istio web cert up there. And what I'm doing up here with the -w is I'm watching what secrets are there. So immediately when I delete this, it's going to say, hey, something went missing. And then it's going to actually create a new one. So if I delete a secret, I can do this many times. If I delete, it's just going to immediately create a new one for me. And this is the watching part. This is what all the rights that the Citadel has, where it's kind of watching all kinds of stuff, watching all the secrets throughout the cluster. This is what it's using. So it's also watching these things. If I now go back to this website, you can see it's now updated, because it got one of the file system events that says, hey, this secret is updated. You now have a new certificate. So we now got a new certificate with a new expiry, because I just killed the old one, and it immediately adds a new one. So this is quite easy to just listen on file system event, know when the certificate is updated, and then change to using that. My worries about using Istio and a service mesh of any other kind is misconfiguration. So let's say we're setting this up, we're adding all kinds of applications to our Kubernetes cluster, and then we mess something up with the configuration. And if we now trusted all authorization, authentication, and everything else to these to Istio, and Istio is not working properly, well, all the security is basically borked. Also, I'm a bit worried about broken access control, because I'm wondering if we're going to see cases where things are not handled the same way in the proxy as in the application itself. We can have some kind of impedance mismatch between how they do URL parsing, for instance. So maybe Istio sees something and says, hey, well, this is okay, but then when it comes into the application, it does a double decode or something, and then it kind of fails regardless. So there are some things to look for. There are also Istio bugs, like we had the timing bugs, but there's been some other bugs as well. So what I would do is I would use some kind of tests, some kind of automated verification tests that checks whether or not you have access and things like that. A side note on bugs, when Istio 1.0.2 was released in September 2018, one of the things that I wanted to fix was a bug in Envoy where the sidecar would crash if receiving normal traffic on the mutual TLS port. That's kind of a nasty bug. It would just kill the proxy immediately if you try to send non-TLS traffic. So there have been quite a few bugs. There was a big blog post a couple of months ago also where someone was writing about all the problems that they had with Istio, and it is still quite new. So, but it looks like there's a lot of power behind it. So, and I think it's going to be quite good eventually, and it's getting there now because they're doing a lot of work on it all the time. Another question that I've gotten is like, are service meshes the new app servers? And what I mean by that, or what the person meant by that, this was, for those of you who have been developing Java applications on app servers, you know that we took out a lot of the stuff that was in the application and we put them in the app server. So the app servers, they would do authentication and authorization, and they would do database connection pooling, and they would do all kinds of stuff. And this is kind of in the direction where Istio is, or Istio does some of these things as well. It kind of pulls things out of the application. And to kind of understand why this is a problem, consider a thing such as service breakers with retries. Like, how would Istio know if it's okay to retry this thing if it failed? That's probably something the application itself knows better than the service mesh. Like, is it okay to try to transfer this amount of money more than once if it fails the first time? Maybe not. Maybe you don't want to do that. So like, use a bit of caution when you're using something like this. That's basically what I'm trying to say here. So to summarize all of this, Istio provides quite a lot of things. Most importantly, security-wise, is this service-to-service authentication through mutual TLS. And this allows us to have encrypted channels. So if we go all the way back to the threats that we looked at the beginning, we now have, even if this attacker is able to breach one of our containers, that doesn't necessarily mean that that attacker is able to attack other containers. The attacker would still be able to try to breach out of the container if the platform itself had vulnerabilities, but at least we've used this to try to protect the services that we have from each other. We can have end-user authentication through JWT. I'm guessing that they might want to add other types of end-user authentication as well. We can actually choose where we want to do the JWT evaluation as well. We can do it either on the ingress, so all the way to the front when the request is coming into the cluster, or we can do it at the proxy level itself. When I tried to do this recently, while preparing this talk, it failed when I tried to do it in the proxy. I can do it in the ingress, but I can't do it in the proxy. I would just get a 503 service unavailable all the time if I tried to do it in the proxy itself. So it had to be on the ingress for now. I'm not sure what's going on. There was a big discussion on GitHub about this as well, why it wasn't working. It might be because the cluster I'm using is Minikube, which is like a one VM Kubernetes cluster, and it's not quite the same as running in a proper Kubernetes cluster. As mentioned, we can do authorization through policies. So we use policies to set up who can talk to who, and if they need to use mutual TLS and all kinds of stuff. And we can, of course, do the rate limiting and the other things as well. With Google being one of the companies behind Istio, it's really easy to set this up if you're using containers or Kubernetes on Google Cloud. Because they've done a lot of work to make it easy to deploy. But it's also quite easy to deploy on a normal machine as well, like for instance on Minikube, because what you get when you download the code is a set of deployment files. So let's see here. Oops. So I've downloaded version 1.0.5 here, and have the old 1.0.1 as well. And in here there's an install folder, and we can choose where we want to install it. So we can say, okay, this is Kubernetes or it's Google Cloud, and there are some YAML files that we can use to install it. There is also an idea about you being able to use Istio outside of Kubernetes. So you can have some workloads that exist on other types of hosts, like just like a normal application running in a VM or something like that. That could also be a part of the service mesh, because the service mesh can be extended outside of Kubernetes through the mechanisms that they've added, which is also quite interesting, because then we're no longer limited to only using this in Kubernetes. Here are some resources if you want to learn more about this. The first part here is the security documentation under docs concept security. the documentation for Istio is super good. I'm really impressed with what they've done, and especially these tasks that they have, where you can not just do security-related tasks, but you can do all kinds of tasks related to Istio. So you can do, you get a set of applications that you can deploy, and then you can set up these kind of circuit breakers and fault injection and all kinds of things through these tasks. So this is a really good way to learn it if you want to try it out. There's also a really good talk called Istio Defense in Depth for Modern Production Environment from Cloud Next last year, which I also recommend that you take a look at if you find this to be interesting. But yeah, the documentation is super good. So you can learn a lot of the stuff that you can do with Istio just by reading the documentation, maybe setting up Minikube yourself the way I did and just install Istio on that, or using Google Cloud for that matter and set it up there instead. So I tried to find a picture to explain what a pod is, and this thing came up. So pods work together. Lights, music, and sounds bounce back and forth. So this is the sidecar on one side and the service on the other. Oh, so, sorry. That's it. Any questions at all? Yes. So trying to rephrase, Kubernetes has a lot of complexity. Istio adds more complexity, and a lot of companies are concerned with this complexity. When will Istio be production ready? That's a good question. I know there are some companies that are now using it in production. I think Nav here in Oslo is using it in production, at least to some degree. There has been some issues with it. They had some issues with like health checks in Kubernetes, as far as I understood from them. But this is something that's being worked on all the time, and there seems to be quite a big, a lot of commits coming into the GitHub repo, and I Google and with Google and these other companies being behind it, I think we're kind of approaching a setting with it. That said, I would never run my own Kubernetes cluster, like try to set up Kubernetes on nodes, because that's a super complex task. So I would probably use this on a cloud provider's Kubernetes setups, like Google Cloud or maybe Azure or Amazon. Any other questions? No? Okay. Thanks for listening.